All right, hello everyone, and thank you for joining us today. As you're probably aware, we're going to be unveiling the KARNO power module for the first time. So to start things off, I'm Thomas Healy, the founder and CEO of Hyliion. And ACT Expo is a show that we've been to for many, many years, but a lot of you probably remember us as a company that was building electric powertrains. That was the origin of Hyliion, and something that we were very proud of. But a couple of years ago, we were here at this show, and we saw a change happening in the industry. So we did have our trucks here, we were doing ride and drives, but I met with a lot of the CEOs of these startup companies that are producing electric vehicles, and we all saw three things happening. We saw that the adoption of electric vehicles was moving slower than we expected. We saw that the cost of components was skyrocketing. And we saw that regulatory mandates were wavering. They were changing. And what we thought was going to be mandated maybe wasn't going to be mandated. So I remember meeting with all the CEOs of these companies, and we were discussing, well, how do we weather this storm? What's the path? And everyone had the same answer of, well, we're just going to keep raising more capital and we'll keep pushing forward. Well, at that same show was the first time that we had shown a glimpse into the KARNO generator. This was a technology that we had acquired out of GE Aerospace, and something that we saw is going to be the right solution for charging batteries on board an electric vehicle. So with that, over the last 2 years, we made the tough but a very proud decision of we actually exited out of the EV powertrain space, and we said, why don't we go all in on the KARNO generator? So there are really three big things that, if you can take away from this presentation, I would love you to, is the first is we're going to need a lot more power. The second is we think the grid is going to move to more of a distributed model and one where you make your own power. And the third is we think this is the right solution to provide that power you need. So let's talk about the first one for a second of needing more power. So 2 years ago at this show, I talked about how plugging in 10 electric semi-trucks was the same amount of power as the entire Super Bowl during game time. Well, as we've gotten deeper into this space, we've realized EVs are one part of the demand on the grid, but there's a lot more happening that's going to be consuming a lot of power. To put this into perspective, a data center is about 100x that amount of power of the Super Bowl. So that means 1,000 semi-trucks is equivalent to one of the new major data centers being built. So as you think about needing power for electric trucks, you're going to be competing against a lot of other industries for that same power. Moving to that second point of a distributed model. So think about how facilities like this, or your home, or commercial buildings, they all have AC systems outside producing cold air for the building. Well, our thought is, why doesn't that same facility just have a box outside that produces all the power that that facility needs? So we think it's going to move to a distributed model. It's no longer going to be build more and more massive data centers, build out transmission lines to bring the power to the end location. It's going to be a model where that end location will make the power it needs. And you couple that with the fact that 60% of the electric grid in the US is already at its life expectancy or past its life expectancy. So as opposed to going and building more transmission lines, let's just make the power at the end location. And then the third is we think this box here behind me is going to be the right solution for providing that power. So with that, why don't we go ahead and take the cover off and showcase the KARNO generator. So this is our KARNO power module. This system is designed to produce up to 200 kilowatts of power out of this compact box. And we see this as a solution not only for EV charging, not only for data centers, but just for standard commercial buildings that need power, or for waste gas applications, or oil and gas sites that are too remote to be able to tap into the grid. Another one that we're pretty excited about is we actually have a contract with the US Navy as well to power future vessels. So we see this really as a modular solution that can go across many applications. The core of it is this 4-shaft system in the center, which we're going to talk a little bit about how it works. But we see this as really the future of how to make electricity. So I want to spend a few minutes to talk about the benefits that this system can provide and what makes it different compared to some of the other power solutions out there. So the first is it's designed for true prime power, 24/7, 365 operation. If you have one of these, you want to be running it all the time. The next is it's truly fuel agnostic. So we've identified over 20 fuels that we expect this box will be able to operate on. And unlike some of the other solutions where you have a platform that then can be adjusted to run on one fuel or another, we've designed this where it's truly this one box can move from running on one fuel to the next, even switch fuels on the fly without the generator even having to be turned off. We did a demonstration recently where we started on natural gas, we then moved over to syngas, and we moved over to hydrogen, then started doing some blends of natural gas and hydrogen, and all of that was done without the actual core being turned off. So as we think about what's the future of the energy landscape, I don't think any of us could predict, is it going to be hydrogen? Will it be natural gas? Will it be some fuel like ammonia, methanol, right? We don't know what the future is going to hold, so we see this as a way to almost future-proof yourself where you can adopt a solution today that can run on many of the fuels that are expected to be utilized down the road. So the next is, this is designed for very low maintenance operation. So Josh is going to cover some of the ins and outs of how it works, but there's no oils, there's no lubricants in this. So think of your car engine, you need to do oil changes. That doesn't exist with this system. There's only one moving part per each one of these shafts, and even that moving part glides on gas bearings or air bearings. So think of an air hockey table. The puck doesn't touch the table. Well, that's the same thing that's happening inside this shaft. That actual centerpiece, the one moving part, is hovering, which allows us to get much, much longer intervals in between needing maintenance. Another benefit is just how compact the system is. So as you compare it to internal combustion engines, we're sitting at about half to maybe a third of the size for the same power output, which is just a huge advantage for if you think about an EV charging site where space is critical. It's a premium, right? And so these boxes are designed where you can stack them next to each other. We're also working on a variant that's a 2 megawatt variant, which think of the size of a 20-foot shipping container. We're able to pack in 2 megawatts worth of power into that box. Now, one of the things that's different about, you think about an internal combustion engine, you move from one power to the next, it's a totally new engine design. With this, we actually just take these 4 shaft systems and pack them together in parallel in order to give you the power you need. So we've really created the building block, and as you need more power, it's like a battery pack where you put more cells together to get the capacity you need. With this, you put more KARNO cores together to get the power out you need. And then the system is, as I said, compact, and it's very quiet operation. So we've had many people up to our Cincinnati facility, and you'd be standing where Josh is next to the box, and you can just have a normal conversation with someone. So and those are some of the benefits that have really been unveiled or unlocked with this type of technology. Now with that, you're probably wondering, well, how does this thing actually work? So I'm going to hand the mic over to Josh, and he's going to do a little bit of a tech deep dive.
You got it. Thanks, Thomas. So my name is Josh Mook, CTO of Hyliion. And as I was reflecting on our time here today, I just couldn't think of a more fitting spot to unveil the KARNO generator. In fact, a little bit of origin story. Over 8 years ago, we were working as part of GE with automotive companies on specifically how are we going to satisfy the needs of the EVs and how hungry they're going to be on the network. And even way back then, it was understood that the electricity network that we had wasn't going to be able to satisfy what was coming down the future if we were all successful. So back then, 8 years ago, is when we started the research and development on this system, and so we're very excited to share it with you today. And to Thomas's point, I'll kind of break down a little bit how the system works and kind of go through some of the basic functionality. So first of all, let's just look at the box and lay it out into a couple pieces. So at the very bottom, we have our high voltage distribution and safety systems. We also have a small internal battery for black start as well as stabilization of the system. Then you see the core right above that. That's really where all the magic happens. That's our 4-shaft system that creates the electricity from fuel, as Thomas mentioned. And then above that, we have balance of plant and finally cooling system on top. So a little bit on how it works. I'll come around here. And what you do is you bring in one of those many types of fuels that you may have available at your site, and we support both liquid and gaseous fuels depending on your application. You bring that in, you react to that at a fairly low temperature, so very low emissions as a result, and then you transfer the heat and only the heat into the core system. So unlike an internal combustion, which is we're often confused with, that fuel-air mixture is actually not reacting with the internals of the system whatsoever. The system is hermetically sealed at the time that it's built in the factory, and it stays that way throughout its entire life. This also helps give us big advantages, as you may imagine, in durability and lack of maintenance, things like that. Once we get that heat into the system, we do that through a series of additively manufactured heat exchangers. And so these are the key unlock to get high efficiency in a heat engine. I have to be able to transfer heat at extremely high rates and very high effectiveness. And so what you'll notice when you come look at this after we're done is there's 3 main components that are duplicated throughout the system that are additively manufactured for the sole purpose of high efficiency heat transfer. Once we get the heat into the system, then it's a matter of you have a trapped gas, you heat a trapped gas, that gas expands, it applies a force on a shaft which is carrying permanent magnets. Those permanent magnets then translate through a series of coils, and we can produce the electricity that's eventually exported to you as the user. And that's all what's happening in here. And then we time it so that each of these are working out of phase with each other, and each side has a symbiotic relationship with the other side. So a couple really interesting things that come from this, and Thomas sort of highlighted it at a high level. But because of the thermodynamic cycle that's been developed, you can get very high efficiency. We're designed for up to 50% of DC efficiency, so that's fuel to electric out. You get that low maintenance that we already talked about. It's completely hermetic, so very quiet in terms of operation. And then with only one moving part, very low wear and maintenance that you would need to touch in the future. So anyway, we wanted to spend some time sort of describing how it works. Now I'll hand it back to Thomas to close.
So there are 2 final things I want to just add to the list of benefits. So the one that we haven't talked about yet is emissions, which is obviously a key thing at this show. So what we found is that due to the way the system works, you actually don't need an after treatment system at all on this. And we're able to achieve NOx and CO levels that are greater than 95% lower than the emissions that come out of a standard reciprocating engine. So that's a huge win. No more after treatment, and being able to surpass standards coming out of organizations like South Coast, CARB, California. And then the last is the question we always get asked is, well, what's the cost of the actual electricity that's coming out of this? And what we found is because it has that high efficiency that Josh mentioned, on many instances, almost all, we can actually produce electricity for cheaper out of this box than you can source electricity from the grid. So now as you think about your EV charging site, where you're often getting hit with peaks and demand, peak spikes for charging rates, you no longer have that when you're sitting here making your own electricity. So those are really the things. So the first was, we need a lot more power, right? Hopefully everyone sees that, believes that. The second is, we firmly believe we're going to move to a model where you make your own power on site. And then the third is, we see this KARNO power module as the way to make power on site. So with that, we'd now like to open it up to if anyone has any questions. We're happy to share more. Yeah.
Can you speak more to what you're doing with the U.S. Navy and that contract?
Yeah, so a question about what are we doing with the U.S. Navy? So the Navy is actually helping fund the development of this. They've selected it as a power plant of choice for future autonomous Navy vessels, as well as other applications as well. So the Navy's been involved for many years in this project. Just this past year, we announced around $20 million in funding that has come in from the Navy to help fund the development of this. One of the unique things with the Navy is they actually are running this on liquid fuels. So this will be run on diesel. So that's another benefit, is this doesn't just need gaseous fuels. We've also are designing it to be able to accommodate liquid fuels as well.
there an MSRP yet?
Questions around MSRP. There is. We have not publicly shared the exact number. For those interested in the system, we're happy to get into greater discussions with you. Just to give you a ballpark, and it's a wide ballpark, I apologize, but recip engines normally around 1,000 to 1,500 per kilowatt for upfront adoption costs. Fuel cells are usually around 3,000 to 3,500 per kilowatt. We're sitting in the middle of those two. So recips are usually around 300,000, fuel cells usually around 600,000. We're sitting in the middle.
Is that a beta type Stirling engine?
Yeah, so the question is it a beta type Stirling engine? So yes, this is formed off of the concept of Stirlings. Quick story there. If you go back 200 years ago, there were recip engines, there were steam engines, there was this thing called a Stirling, and Stirlings were always thought to be like, this is the best way to make power. The problem was they were damn near impossible to manufacture. And so what we've done, as Josh talked about, is we've taken 3D metal printing, additive manufacturing, and we've unlocked that manufacturing capability. So we're basically taking 200-year-old technology and bringing it to the forefront with new manufacturing techniques.
What is your transfer medium? Is it like helium?
Yeah, the question is, what's the transfer medium? So yes, it is helium, as you mentioned. So what that means is, as Josh talked about, we have a trapped gas on the inside. That gas is helium. Our whole goal is we heat that gas up. When it gets hot, it expands, and that's what pushes the piston down one way, and then you do the opposite reaction on the other side and push it back. Any other questions? Yes?
How much of the design of what's inside the generator is something that you developed, and how much is through suppliers and partners?
Yeah, so the question is, how much of this is designed by us versus suppliers? So I'll let Josh cover this because it's something we're really proud of.
Yeah, we've designed 100% of what you see here. We own all the intellectual property associated with that as well. So we obviously use, third-party manufacturers for machining and things like that. But even the additive manufacturing, we do 100% in-house in our site in Austin, Texas.
And one more.
Yeah.
So let's say you have a 200 kW diesel right next to it, right? What would be the fuel consumption there, compared yours to what we all know is diesel?
Yeah. So the question is fuel comparison against our system versus a diesel reciprocating engine. So as we spoke about, this is at a 50%, it's designed for a 50% fuel to electric efficiency. A normal diesel recip will likely be in the 40s, low 40s, right, sort of a number. But then you need to convert that into electricity, which then means you're usually going to be into the 30s even with that. So with that, recips making electricity usually in the mid high 30s. We're designed for the 50% mark. So put that in comparison. You take a US wall outlet, plug your phone in to charge it. The US grid is 36% efficient. And so from that standpoint, if we can achieve that 50% efficiency, you're actually able to make your own power more efficient than most of the power in the grid in the US. All right. Well, with that, thank you all for coming for this unveil, and please stick around, talk to our team, ask any questions you have. Thanks, everyone.